This is a lesson for year 10 and it's on the rivers unit, and it's week 2 of the rivers unit, where we're going to, over a course of 3 lessons, look at river long profiles and cross profiles. We're going to look at drainage basins, and then finally we're going to move on to river processes. This is lesson 1 of week 2, in which we're going to look at more generally at drainage basins. Just a reminder, last lesson, you'll see on the slide in front of you, we were looking at how a river changes from source to sea. And we said that the source was the start of the river and it's always high up, and that gradually that river loses height and loses steepness and eventually flattens out and makes its way to the sea. Today's lesson, in a moment you're going to answer some questions, some recap questions on that, and then we're going to be making a pop-up drainage basin in your books. If you're doing this lesson from home, you might not be able to make the pop-up drainage basin, but you will still be able to follow along and understand what we're doing and get the correct learning outcomes out of it. So, first of all, your Do Now quiz. If you would like, I'll just move my webcam out of the way so you can see the question. If you press pause now, attempt to answer all of those questions, and then I will go through the answers. Press pause now. Okay, so let's have a look at the answers. How many sections are there in a river's long profile where there are 3? The upper course, the middle course, the lower course. What do you call the point, for question 2, what do you call the point at which 2 rivers meet? Well, the point at which 2 rivers meet is the confluence. If you remember the demonstration we did in class, where one student was demonstrating, or 2 students were demonstrating out, we said the confluence is basically the armpit. If the arm was one river, and I suppose the body was another river, the point at which they meet is the confluence. So confluence. Question 3. What do we call the start of a river? The start of a river is called the source. So the start of a river is called the source. S-O-U-R-C-E. Not as in sauce, as in ketchup. Number 4. In which course of the river does vertical erosion dominate? So the answer is the upper course. So in the upper course of a river, the river generally erodes downwards. It's trying to lose height rapidly as it makes progress towards the sea. So in the upper course, it's usually vertical erosion that dominates. And in the lower course, as the river's got less gravitational potential energy, it's more lateral erosion, which means erosion sideways. So question 4. Upper course or vertical erosion. I've probably already given away the answer to question 5 in my last explanation. Which part of the river has the greatest gravitational potential energy? The upper course, because it's very steep, there's a lot of height there, so it's got a lot of potential energy, and that's due to gravity. Now this one I kind of put in as one to make you think, and I got some pictures to explain it on the next couple of slides. So why might the steepest part of the river not be where the river flows fastest? Why might the steepest part of the river not be where the river flows fastest? Well, it's to do with how much water is actually in contact with the river beds or the river banks. So the steepest part of the river is certainly where you might have the most gravitational potential energy, but the steepest part of the river isn't all like this. It's not all vertical. Some parts of it will be flat. Remember, the upper course of the river is very narrow as well. It's very narrow and small. In the lower part of the river, there's far more water which is actually free moving, not in contact at all with the surface of the river channel, and therefore it can flow quite fast. I'll explain that hopefully in the next couple of images. So we have a look at these 2 pictures typical of the upper course. So obviously the water in this picture here, of the waterfall, is flowing very, very fast because it's falling over the edge there and it's flowing at a huge speed. But a lot of the upper course will be like this picture on the left here. And we can see here that actually if you look closely, a lot of the water is in contact with rocks and in contact with the river bed. Now that's going to cause drag. So as the water is flowing over, if it's in contact with rocks and it's in contact with the river bed, then actually it's going to slow it down because of friction. If we look at what a river looks like perhaps in the lower course, you've got a nice wide river here, huge parts of this body of water are not going to be in contact with the river bank or the river bed at all. So it's free flowing water, there's no friction slowing it down. So because of less friction, water in the lower course of the river can have, on average, will have a faster velocity. So yes, you're going to have water gushing down waterfalls, and obviously that's going really fast. But on average, the velocity of a river is going to increase as you go downstream because there is less friction between the water and the river bank and the riverbed. Okay, so this next part of the lesson, we're going to look at drainage basins. Before I talk about drainage basins, I want to go back a step to talk about the slightly bigger system of the hydrological cycle or the water cycle. So the water cycle or the hydrological cycle just describes the movement of water around the various different stores on the planet. The water cycle is finite. It's a closed system. That means no water can be added to the water cycle and no water is ever lost from the water cycle. The water just simply cycles between all these different stores on the planet. There's lots of different stores. Water can be stored in the atmosphere in terms of clouds and rainfall, etc. Water can be stored in the oceans. It can be stored in what we call the cryosphere, which is ice and ice caps, glaciers, ice sheets. It can be stored in the ground, in the soil and rocks, and pore spaces between rocks, and we call that the lithosphere. It can be stored in plants and animals, and we call that the biosphere. And us, of course, we're part of the biosphere. And terrestrial waters, which is rivers and lakes. So all the water cycle does is it just describes how water moves between those different stores. And water's constantly moving. And some stores hold on to water for a long time, like ice and glacier can hold on to water for a long, long time. And other stores, like rivers and lakes, will see water moving quite fast through its stores. The drainage basin system is slightly different to the water cycle in that it's an open system, and that means water can be added to and lost from the system. A drainage basin is an area of land drained by a river and all of its tributaries. So if you have a look at this particular drainage basin here, it's this whole area of land within this dotted line called a watershed, that is drained by this river here and all of its tributary rivers that flow into it. Drainage basins, we look at drainage basins and we define drainage basins because it's useful to know how a river might respond to a heavy rainfall event, which may lead to a flood. It's useful to know for agriculture and other purposes how water might behave or how long water might stay within a particular drainage basin system. So I suppose a drainage basin system, in a way, is a small water cycle within a given area that you're looking at. Now, drainage basins can vary massively in size. They can be like the River Nile or the Amazon drainage basin, which is absolutely huge. The Mississippi, which I think we'll look at in a moment, which is a huge drainage basin. So any single droplet of water that falls within this blue line is actually part of the Mississippi drainage basin, will eventually, unless it's lost through evaporation and other things, make its way into the Mississippi River. It's a huge drainage basin. But similarly, a small river will also be a drainage basin because it is responsible for what happens to the water within that particular area. I quite like this picture because it shows quite nicely. This is drainage basin 1. This on the left here is drainage basin 1, and this on the right here is drainage basin 2. This area of high land usually separates out one drainage basin from another. So what we're saying is any rain droplet or any form of precipitation that falls on this side of this high land will form part of this drainage basin here. And any droplet of water, precipitation, snow, hail, whatever, that falls on this side of the highland will form part of this drainage basin here. So a drainage basin is an area of land usually separated by a ridge of highland. It's an area of land drained by a river and all of its tributaries. So one drainage basin here, one drainage basin there. What you need to know is what the features of a drainage basin are, and that's what we're going to look at today. So obviously if you're isolating at home, you might not be able to do this bit. You might be able to. All you need is a pair of scissors, something to draw a circular template round, a couple of pencil crayons, blue and brown, a pen and a stick of glue. You don't really need your stick of glue because you don't have your book at home, but all the rest of it you can, and you can bring it in. If you don't have those things, keep watching. I will be skipping through the actual, I suppose, doing bits, and what I'll be wanting you to focus on is the different labels and what goes where. Oops, my computer's just had a bit of an issue. There we go, it's back. So step one, if you're making this, you need to cut out the template exactly as shown there. You need to draw that triangle on, and you need to draw that line on there as well. Okay, so that's number one. You cut out the template, and then you also cut up this vertical line here. Step two, you're going to, with a brown pencil crayon, draw around the circumference, that's the outside of the circle, not the bottom bit, because that's going to be a river, just this bit up to the triangle. Step three, using a blue crayon, you're going to shade in the left triangle, and then you're going to draw on some streams and tributary streams flowing into that. Step four, you're now going to add on these numbers, and this is something you can do. So again, if you're not making this, you could draw this in your book or on a piece of paper, and you can actually still label these sections. So the watershed. Watershed goes on this brown line. The watershed is the area of land that forms the edge of a drainage basin. It's like the boundary line of where the drainage basin. Any bit of water that falls outside of that boundary line is going to flow into the next drainage basin. The source is where the river begins. You need to find the blue line that is closest to the watershed that you've drawn, because that will be your source. That's the point to which the river starts. The mouth is going to be this bit here. It's going to be at the bottom of this blue channel here, because it's where the river meets the sea. Confluence. You can draw a confluence anywhere where two rivers meet. So the exact point where two rivers meet, the armpit, if you remember, of the river. Where are we at? Tributary. Any smaller river joining a bigger river is a tributary, so you can draw any of them on. The channel, this is where the water flows. So the river channel is the actual channel through which the water flows. So this bit here is clearly a river channel because it's got loads of water flowing through it. And obviously the drainage basin is the whole thing. If you were to glue this in your book now, you would glue that right-hand triangle, stick the blue triangle over it, and you fold it over, stick it in your books, and abracadabra, you get a lovely pop-up drainage basin. It would be good for you to make sure you've written down all of these definitions 1 to 7 in your book. So you've got, or on the piece of paper if you're working from home. So you've actually got some clear definitions there for when you come to revise. These different keywords are important. You could be asked for the meaning of them in an exam, but more importantly, whilst we're talking about rivers and drainage basin and flooding, I'll be using these words and you'll be using these words frequently. And one of our exam feedback, one of the key things we noticed, if you remember, was people were dropping marks because their geographical terminology, they were being quite clumsy with language. So using these keywords is important. Where are we at? There we go, Blue Peter badge, congratulations. That's his template I put in. Okay, so that is the end of the lesson. There is a homework set this week as well. Do have a look on Google Classroom. There's 2 exam questions this week. One is based on the cross profiles, and one is based on transportation, a river processor, because that's what we're going to cover the next 2 lessons. If you're isolating for the rest of the week, there's going to be 2 more videos I'm about to record in a moment for Tuesday's lesson and Wednesday's lesson. I hope you're back in school and feeling better soon.